Welcome back. So here we are going to solve simple trigonometric ratios. And what I mean by simple is just that it's going to be sine is equal to, cos is equal to, tan is equal to, or it's going to be some kind of simple rearranging of the equation. So you've solved for angle before in previous courses, right? So if I wanted to solve for an angle, I would take the sine inverse, the cos inverse, or the tan inverse to get theta by itself. And in Math 20, we talked about this kind of a question where, say I gave you the ratio, and I said, okay, sine theta is equal to a half, right? Positive a half, right? Specifying there's no negative sign in front of that half there, right? And what we know about this is that based on our cast rule, sine is positive in the add and the sugar quadrants. Add sugar to coffee. It's positive here and it's positive here, so it's not in these bottom two quadrants. So it's in the top two quadrants. So I should have two answers that would get me a half. Two angles that would give me a half. Actually, I have an infinite number, but within one circle. Most of the time we limit ourselves to a circle. We may not. We might limit ourselves to the top half, the bottom half, a negative circle, a positive circle, right? Or a couple times around the circle. So we might have more than two answers in this situation, or might just have one, depending on how we limit it. But we know that because this is positive, it's in these two quadrants at least. If I'm in a full circle, like this one down here, then I have two answers. I have the answer of this standard position angle or this standard position angle. So one of those two thetas, and both those thetas will get me, depending on what they are, like if I can figure this out, and I could do that quickly, sine a half. Remember, sine is the y values, where on the unit circle is the y value a half. Well, it's a half at 30 degrees. Or you could think of that as your triangle. This is my y value. That means this other side is this side. What does this angle have to be? Because the sine is the opposite over hypotenuse. So this would have to be a 30-degree angle. So we know it's 30 degrees. And then this over here, because this we usually solve for these triangles, the reference angle, this is also 30 degrees. So 180 minus 30 will also give me 150 degrees. And then you can just verify it. Make sure your calculator is in degree mode. And you go sine 30 and sine 150, and you both get a half. Right? So what I'm going to do is I'm going to go through the steps of how to do this through this example. Okay? So also this might just be a review of Math 20-1. Depends on your teachers. They may or may not have done this kind of stuff. They should have, no. So what we're going to do, first of all, we're going to look at the ratio, sine, and we're going to look at the sign of the ratio, of the symbol, right? So we know it's sine, so I'm going to be looking at which quadrants sine is negative in, okay? So everything is positive in the first quadrant, so I'm not in this quadrant. Sine is positive in the second quadrant, so I'm not in this quadrant. Because I'm dealing with a negative sign, it's got to be in this quadrant and this quadrant, okay? So sine is negative. So that's my first thing I was looking at. Sine is negative to decide which two quadrants it's in, okay? Look at the restrictions. 0 to 2 pi, so this is 0 to 360, so this is the whole circle. So I have both of these quadrants to deal with. Sometimes that might just cut off quadrants, and maybe you'll just have to deal with quadrant 3 or just quadrant 4 here. But I'm in these two quadrants. So I'm in quadrant 3 and quadrant 4. The second thing I'm going to do is try to determine what the reference angle is. Now the easiest way to get the reference angle, and sometimes this is the best way, just pull your calculator out, and you take the sine inverse of the positive number. So remove the negative. So if you want, you can put little absolute values in there. So just don't put the negatives in there. Just go sine inverse 0.5 or 1 over 2. And what we get is 30 degrees. So there's my reference angle. Okay. Then what I'm going to do is I'm going to just redraw this picture. You don't have to. You just put it over that picture we have. We're going to put those reference angles into this picture. And now we're going to try to determine the standard position angles to both of these terminal arms. So what are those angles? So theta in this case is going to be 180 degrees plus the 30. So it's the whole top and a little bit more. So I get 210 degrees. And theta is also 360 minus that 30. So it's the whole circle, and then back it up a little bit. Just get rid of that extra 30 there. So I get 330. And then step 4, which most time you should be doing, is verify. Right? It's pretty easy to verify. You just put these two numbers in your calculator. Sine 210, as long as you're in the right mode in your calculator, and sine 330. Hey, negative a half, and then sine 330. Oh, another negative a half. Okay, so both of these give us negative a half. So just verify that's correct. Also, another verification tool is just use technology, right? So you could graph this, okay? So I'm going to pull up my graphing calculator here. This is my graphing calculator. I'm going to graph. What am I graphing here? Sine theta and negative a half. Okay, so I can't use theta, so I'm just going to graph sine x, and then I'm going to graph negative a half. Oops, negative a half. Okay, so you can see it crosses a bunch of times here. I'm just going to make sure I'm in the right mode. Okay. There's no zoom trig. If you're in your calculator, you can just go zoom trig, and it's going to zoom your window to the proper way. I'll show you that in a different video. But why not just use Desmos? You're at home. You can just use Desmos. I'm not going to stop you. It's a pretty cool program. But we have a limitation here. So if you go back to our notes here, it says that we have to be between 0 and 2 pi. Oh, actually, I should probably go back and change these angles here, because I've done everything in degrees, but the question is in radians. There's a radians right here. So these have to be in radians as well. So I'm going to change these quickly to radians. Okay. So the first one is 7 pi over 6. And the next one is going to be over 6 as well. 11 pi over 6. You know, so I like to do a lot of things in degrees because it's easier to write degrees. It's easier to do them subtraction and minuses. There's no pi symbols. But you have to be very careful. If they give the question in radians, then you have to answer your question in radians. Right? Now, remember to change these. We're going to go, so this is how I would do it. I would set up a ratio. Pi is to 180. What is 210? Right? And then pi is to 180. And what is 330? I just solve for those two question marks because you want to leave these as exact values. Remember, you can just cross multiply, you divide, but you really just divide the two numbers. You leave pi alone. Pi is a number, but it's an irrational number, so you just divide the two whole numbers. So I want 210 divided by 180, math, enter, gives me my fraction. And then you just put the pi back in there. Okay. Now, so if I'm going to use technology to do this, let's go back here. I'm going to make sure that I'm in a good mode. You could do this in radians, but sometimes doing this in radians, when you're looking for these intersection points, this time Desmos actually gives us a nice answer here, 7 pi over 6 and 11 pi over 6. But we also have a window, so you can go here to this little wrench icon and change your domain. Say, okay, I'm going from 0 to 2 pi. So you just hit pi for pi. And I'll replace it with a pi. You can set your steps here to pi as well. So you can see it changes the scale to use exact value pi's, which is kind of nice. So it goes all the way to 2 pi here. Just going to zoom out just slightly. All right. Maybe you can hold down Shift. You can move this around. If you hold down Shift, it does a zoom. If you hold Shift on the axes, you can zoom the axes in and out. Make this look a little bit nicer. Yeah. And then if I click on one of the graphs, you notice that there's gray highlighted boxes here, like all different places, the boxes, little dots. They represent key points, like intersection points. You just click on them. So there are my two answers, 7 pi over 6 and 11 pi over 6, which we already knew. All right. You could do this on your graphing calculator as well, your TI calculator. So you would put in the first one, sine x, you put in the next one, and then in your window, make sure which mode you're in first. First thing I would do is go zoom trig. So go zoom, then trig. All right, I can't remember which one it is. That's number 7 here. All right, so zoom number 7, so trig. That will zoom you to the right window of your mode. So if your mode was in radians, it would zoom you to the proper radian window. If you're in degrees, it would zoom you to the proper degree window, from negative 360 to positive 360. Then you go to your window. Let me just double check what I'm in here. And you go to your window and you change your domain to match. And my domain was from, let's change that x min to 0. My x max, let's keep that at 3. They put down 352 when you go to that, but let's go down right to 360. You can leave the scale as 90. There's every tick you see is 90, and then you have the max and mins. You can leave those where they are, and then you're going to do some intersections. What is this? Second trace intersect. Right. If you're in degrees, you get nicer numbers. If you're in radians, you don't get the nice numbers like we do in Desmos. In Desmos, they give you this nice exact values here, but in your on your calculator, it would give you decimals. Right. It's harder to change those decimals into fractions. You can do it. Now maybe I'll show you how to do it, but it's a little bit harder to do. Cool. Okay, so here's a couple of examples. Now these examples here, what we're going to try to do is we're going to try to use our unit circle knowledge as to the best of ability. Like you could do this the exact same steps that we just did there. Take the sine inverse, find the reference angle, find out which quadrants it's in, then find your standard position angles based on the domain they give you, right? But we can also try to use our knowledge of unit circles to try to speed this up. Okay, so what I know about this ratio corresponds to 45 degrees, right? So whenever I see 1 over root 2 or 2 over root 2, I always think 45 degrees. And if I know that this is 45 degrees, but you can also verify that. You go sine inverse, 1 over root 2, and you get 45. So as in the degree mode, you get 45. So the first thing you want to do, well, there's lots of different first things you could do. One thing you could do first is determine what is the reference angle. Ignoring the negative, you get 45 degrees. Next thing you're going to do, which is the first thing I would have done, is determine where is the sign a positive number. This quadrant and this quadrant, because add sugar to coffee. It's not going to be in this quadrant or this quadrant, so it crosses off. The reference angle is 45 degrees. I'm going to put 45 in both of these spots. And then I want to determine the standard position angles. So those two angles. So one is, because the reference angle and the standard position angle in the first quadrant are the same, one is 45 degrees. And another is going to be 180 minus 45, which ends up being 135. Double check your domain. One circle around, so these two numbers fit within that domain. So there's my answer. All right, so we could do the same thing for this next one here. To find my reference angle, I would go tan inverse, just the positive number. Okay. I know it's going to be one of those 30-60 numbers because I've seen this ratio before, but why try to use the unit circle when sometimes it's just easier to type it in your calculator, take the tan inverse of this, and you get 30 degrees. Okay, now tan is positive, or sorry, tan is negative in, that sugar to coffee, okay, not the all quadrant because everything's positive, not the T quadrant because that's where tan is positive. It is positive, or negative, sorry, these two quadrants. I talked about this before. That is a straight line, just based on the rules of intersecting lines like this. Because these two angles are the same, this is going to be a straight line. So 30 degrees for my reference angles, and I want to find these two standard position angles. So my standard position angles are going to be 180 minus 30 degrees, and yeah, we've done this before, 360 minus 30 degrees. So we get 150 and 330. You can just double check that in your calculator. Now, when you punch this in your calculator, if you go tan 150, you're going to get this decimal number, this negative 0.577 number. You can just verify that by punching in negative 1 over root 3. Yeah, they're both the same number. And then also tan 330 is also negative. So yeah, these worked. For the next one here, because it's secant, what I'm going to have to do is look at my formula sheet, realize that secant is the same as cosine theta. So I'm going to write that out. So you notice I just changed this. I didn't change the other side because this other side is just negative root 2. There's no reciprocals there. So I take the reciprocal of cos to get whatever secant is here. Then I'm going to rearrange this to get cos by itself. So I'm going to multiply the cos up to the other side, divide the root 2 down. This is now what I'm going to solve. So I'm going to get my reference angle by going cos inverse. You notice I'm using the ratios that they give you, like tan inverse, sine inverse, etc. Okay. Looks like this is going to be 45 again, but I'm just going to double check. Yep, 45 degrees. So we have 45 degrees. Then I go in here and I say, oh, the cos is negative. Whereas cos negative is not in the first quadrant because that's A. It's not in the fourth quadrant because that's where he's positive. So he is negative in these two quadrants. So I put my reference angle in there. And we solve for our standard position angles. You always solve for standard position angles. When they ask you to solve for theta, angle theta, always find your standard positions. So one's 180 minus 45, and one is 180 plus 45. So you get 135 like we had before, and 225 for this next one. Yeah, there you go. Looking pretty good. Okay, so what I want you to do is I want you to try these next three here by yourselves, the same procedure that we did up here. All right, same procedure. Try it out and go.